relies heavily. Sorry.
Yeah, please continue.
Yeah, what I was saying, this SME sector relies heavily on, say, regulated on instrumentation, and that are just connected one after the other. They are not like uniform across the whole plant or anything like that. But against any other country in the world, I would say, even for those SMEs, the data at least exists. They have some PLCs, they have some SCADAs, sensors, and instrumentation installed over there. So yeah, they have the basic that is required for AI implementation. And that's where we come in. We are trying to get those people to adopt AI. We try to convince people that they should adopt AI and move forward. That is the next thing, that is the next biggest thing for all the industries across the world.
So you are essentially saying that there is a reactive maintenance and there is a problem of safety in that sense, right? When it comes to industrial plants, because they are largely.
Yeah, when it comes to, say, Indian industry, there are two things that they follow. One is run to failure, and the second one is calendar-based maintenance. Right.
Okay.
Both are costly.
Okay.
Right. So that's the reason, either their machines run to failure, and if they have a calendar-based maintenance, they maintain the machines whether they need it or not. The machines need it or not. That's where things should change. See, automation gave them control and alarms and some things to work with, but it didn't. The automations don't have a foresight. The AI gives them the foresight.
Right. Understood. So is this where, on a factory floor that you thought like this is the problem I would like to solve? This is where I would like to innovate.
A lot of times, say, the first thing is the predictive maintenance. What I would say, I have seen in plants that they, for example, there is a conveyor belt, a heavy machinery, a conveyor belt, and then it breaks down. The whole line gets hung up there.
Okay.
Because they could not predict that this is going to happen, and they didn't take up the maintenance on an off day or a particular schedule. So these things always have bothered me. And since with the AI technology being booming across the world, we thought that we should again combine AI with industrial automation, which we have been doing for quite some time, to come up with solution that is important for part.
Right. So I understand. Yes, I guess. So I understand how you are pairing or sort of adding this layer of AI, but I would still back one step, and I would still like to ask you why the industry has lived with this problem, because this is definitely not a new problem, what you are saying, right? Because sensors, SCADA, and automation have existed for decades. So why wasn't that solved earlier than this?
See, that's the issue with not only Indian industry, but a lot of industries across the world. Because they had the data, right? But they didn't have anything that would predict a failure for them. So that's the gap that has been existing, and that's the gap we are trying to fill here.
Sorry, Saikat. The place where I am in, I am getting a fire warning, and I'm fire safety thing. Could you give me just 2 minutes to see what's happening? Audience, really sorry for this. Since I would like to host the next one also, I'll take this warning seriously. But just give me a little bit of time. Yeah. Hello. Hi, Saikat. Hi. Am I audible?
Yeah, you are audible, but I can't see you.
Yeah, I'm just turning it off.
So,
yes.
Like,
Yes, guys.
what
Sorry,
was the,
we had a fire drill apparently, so I just came out of the building. Let's
so
continue. Yeah.
so the thing is that here where AI would have helped you with your
That's a
CCTV
good.
cameras and
Yeah,
all the thing.
yeah. Right. We don't have to be so reactive when it comes to this kind of safety
Definitely,
things. Let's that's a
definitely.
good segue for us to go into a case study of, let's say, give me an example of a plant where this is, the predictive intelligence would come into play in a situation like this, which is more serious than what I just had.
I would give you an example of one of our product, which is has predict. And in power plants, say in other many areas, there are a lot of gases that are being used. Some of
Mhm.
them use different kind of gases, CO2, hydrogen, ammonia, chlorine, all those. And there are leakage detection systems that are already installed over there. What they do is there are two levels. One is high and one is high.
Okay.
And at high, it gives out an alarm. But the problem is the concentration of the gases have already reached a dangerous level. What our system does, it intelligently calculates the rate of rise of the concentration of those gases
Mhm.
across there. And it gives out an early warning saying that maybe you have 8 minutes or 10 minutes to evacuate before this gas cross a dangerous level.
And that's a very short time.
Even if it is a short time, still you can organize things properly and you can evacuate all the personals out of a danger there.
Understood. Understood. As opposed to when you're saying there is just a black and white way of saying, okay, it's at this level
Exactly. Instead
and
of
it's at that
just
level,
having
right?
instead of just having a black and white kind of thing, just an alarm with a dashboard just shows you saying that okay, it has crossed high level. Problem
Okay.
is the
Okay.
data is always there, but most
Mhm.
of the people are overloaded by so much data that they cannot analyze the data. You need a small plant cannot have a data engineer sitting there. They cannot afford to have a data engineer sitting there continuously monitoring the data and coming up with a solution. That's why you need AI
Understood.
to do
Understood.
those.
Right. So before I got cut off from the call, I was asking. So the industry have all these problems, but sensors and SCADA and all these automations have existed for decades. The only difference is AI. So are you saying the problem is so specific, and the technology is enabled in a particular way that only now we are getting the solution for it?
Definitely, that's what I'm saying. Because as I mentioned, once you have a lot of sensors and SCADA and PLC installed, the data exists there in historians in your databases, but people are overloaded with the data.
Okay.
Even the
Okay.
operators, the engineers, they cannot analyze or correlate to different kind of data which are totally disconnected, which AI can do.
Mhm.
This has
Okay.
been a gap for quite a long time, and now with AI, we have a solution for this.
Understood. But for years, we have talked about Industry 4.0, IIoT, and smart manufacturing, right? So, where are the Indian industries on that journey? Like, what is the high? What is real? What is ground reality?
Let me be very honest with you. The audience has heard these buzzwords for a long time.
Yeah, yeah.
Most of the industry 4.0 became shelfwares, basically. Okay,
Mm-hmm.
dashboards, nobody opened, digital twins with 3D models with no live data inside. That's where the problem was. So actually, what worked
Mm-hmm.
behind the scene was they got, which was not glamorous at all, is they got sensors, they got the connectivity, and they had the gateway, which is the
Understood.
ground level of any kind of building to AI. So what I think is first point is you get connected with all your machineries, different monitoring system, then you monitor them, then you analyze it, then comes the predictive, and then things become autonomous. It's a ladder. It's a continuous
Understood.
process. Yeah. So
Understood.
one above the other. One layer is always built on another layer before that. So what Industry 4.0 did was just getting connected and monitored. Some are in the monitoring phase, but then no, some are only at the connected phase. So
Understood.
yeah.
So I would like to go one question back because I wanted to ask you something particular regarding the costing side of this, right? Because you said all these reactive maintenance and safety issues happen where we cannot, predict things as with the current system's limitations. So what is the costing like that for them? Like what sort of downtime is happening, and
See, that's
how
what.
can we improve that? Yeah.
Yeah. So you see, there are two things. When there is a downtime, two things are being calculated by any company or any manufacturing company: is mean time to failure and mean time to repair, or time to repair.
Okay.
Okay. So how much time after each of them? It's like after how much time of equipment is going into maintenance or failing, which is going into maintenance, and how much time is being consumed to actually get it up and running. Right. This is where your ROI mainly resides. If you can predict a maintenance, say, I would say you have a rotating machine, any kind of, say, a compressor or anything, and then you get an early warning saying that this might get into failure. There is a problem in the vibration. With the vibration sensors are showing that there is a trend that vibrations are increasing, creeping up slowly. So there might be an issue with the specific signature of the vibration. There might be issue with some of the bearings that is connected to. So what happens? This warning comes on Friday. So on Sunday, they can take up maintenance of that. They replace the bearings and everything. And on Monday, the plant operates normally. Instead of on Wednesday, the bearing actually fails and the whole plant is stopped.
Understood.
So
Understood.
these are the places where ROI actually resides in a plant.
I would like to explore this with you in details across different industries, and within those industries different areas. But I would like to just address something that most of our audience might be thinking, that is when you already have an existing system, right? So and a factory wants to move on from that sort of a manual monitoring to a predictive intelligence thing. What physically happens? Like what do they put on the machines? Do they rip out the entire wiring, or like what happens actually? Could you give us a picture on that?
Definitely. See, unlike most of the things that came before this AI integration with the automation, people wanted you to replace your existing infra with a costly and more complicated system. What we do is
solutions before AI, right?
For AI. Okay. And even with AI, people would like to do that. But what we believe in, that our systems can be connected to any legacy system that already exists. So see, you might have a vibration sensor already installed in your motors or rotating machines. Okay. We won't do anything. We will just tap in the signal directly from there to our system, which can give you a predictive analysis of the motor itself or the rotating machine itself. So you don't need any fancy new installations. If you already have some sensors, temperature, current measuring equipments, we just hook up to the existing system. You have a SCADA, you have a PLC, we'll hook it up to that. We won't ask you to change.
Okay. So we have to come back to your specific use cases. We have a lot of people, I'm sure, watching from across manufacturing, right? So we have automotive industry people, textiles, pharma, food and beverage. So can you give us a specific example of how how a company when they start this journey, what is the most common industrial cases? And Saikat, I hope my audio is still clear because there is a bit of things happening regarding
the. It's clear.
Awesome,
It's
awesome.
clear.
So yeah, so in automotive industry, textiles, pharma, or like food and beverages, could you give me a some context on that specific
Definitely.
industry?
See, the most common thing you will find across almost all manufacturing industry is rotating machines. That's what I said. Pumps,
Okay.
motors, compressors, and all those things. So this is the first, I would say, is the entry point for most of them. Okay. Then
Okay.
comes the power side, where they can increase the efficiency, power efficiency, how they can uh, keep the power factor in limit, how to save energy with different areas, which areas is consuming more, are consuming more energy, and then they can analyze why those things are happening. Is it the fault of the
Mhm.
instrument or the fault of the wiring or something like that? So that's how they can grow slowly. Then comes the say maintenance part, scheduling,
Mhm.
scheduling, automatic generation of work permits, work orders to the vendors, which uh, or materials you might need for the maintenance, and is it present in the store? You already
It's
have that
not
in
just
stock.
so you have. It's not just an engineering aspect of this AI implementation, right? So there is what you're kind of connecting to is also an operational thing.
See, that's what it is. It starts at the very basic industrial operational level first, and
Mhm.
then you slowly build onto it to get to a higher point where most of
Mhm.
the things can work autonomously. We don't say that the AI is going to take the decision and send out the work order to any of your customers, but it can prepare it for you and it will give it to you in front of you to approve. So
Okay.
you
So
can go through
so
the, yeah,
so no. So if I'm a shift manager, like, or a production manager, can you give me like a for instance case where how this will help me?
definitely. And now, if you are a product manager, or say you are a production supervisor or anything on the shop floor, right? So
Mhm.
now you know that your AI has given you that there is a 98% probability or chances that this two rotating machines are going to go into maintenance or going to fail. So you know
Mhm.
it before. You can now see that the PIMS, what we call it as a plant information management system, those systems actually will uh, say determine, do you have the
Mhm.
spare parts need to take uh, carry out the
So all,
maintenance.
yeah.
So, and it will
Understood.
see if even if it is there, if it is not there, so what
Mhm.
is the lead time to procure them?
Okay. Okay. Okay.
It is
Okay.
going to do all those thinkings, and then it will give out a warning or something on their screen or dashboard saying that we have to order this thing today. We
Mhm.
need it in stock before, because next week we are trying to plan a predictive maintenance of some system. So this,
Okay.
it is not only one thing that AI connects. You cannot think
Okay.
of the plant as a disjointed system coming together. It's a living organism. You have to think it like a living organism. Everything. There are
Mhm.
senses, there are brains, there are um, different organs doing different things. So to keep a human being healthy, we have to take care of all of them. Similarly, even in a plant, we need to look after all the different aspects of the plant itself.
Right. Right. So just to summation, to create a summation, we spoke about the AI's solution to, let's say, vibration, temperature, motor current. You spoke about the flow. So all these things, but at the same time, we are also looking at just not a problem. It's not projecting just a problem, but also the solution and all the operational side of that also, right?
Yes, yes,
So I
definitely.
would, you know, I would like to ask you, like, because every solution is calling, there is an AI thing,
Your
AI thing.
voice is breaking up. Can you repeat the
Sorry,
question?
sorry.
Your voice is breaking.
Yeah, no. So there is a AI thing buzzword all around us, right? So I would like to get your answer on very, very briefly that what is actually inside the tools or the products that we're talking right now? Like, what is there an LLM layer? Is it like there is a detection model happening? So what's happening?
uh, like when you hear about AI, most of the people would think it's a LLM, like ChatGPT or Gemini, which we see on a day-to-day basis. But that is just one of the models of when it comes to AI.
Mm.
There are machine learning models, ML models available. Like for example, if you say predictive maintenance, I would say Holt-Winter's model of ML, which
Okay,
is
okay,
mostly used. Okay, so
okay,
they are
okay.
not LLMs. They are not LLMs. Those kind of models. Okay, then you have
Mm.
Z-score. Okay, those models, you feed raw data into it. It learns from the data what is normal for your plant. Once it is installed in your plant, it is gathering the data for next few months, and it
Mm.
learns what is normal for your plant. What are the deviations in day-to-day things that is almost happening? And then it starts predicting, okay, this is normal for the plant, but things have been deviating slowly out of those
Mm.
normal zones. Then it goes through the data again, what is deviating, how it is deviating, and then it analyzes and gives you an
So it's like having multiple agents, talking to each other. And yeah, yeah, yeah.
each.
And Saikat, so yeah, sorry, please continue.
So it's like a engineer having a junior engineer whom he said that you have to look after this data and
Yeah,
tell me whenever it starts drifting.
understood, understood. So I'll ask you the big question. A lot of plant owners are actually worried. I mean, most of us are worried, but still in this context, a lot of plant owners are worried. Does adding an AI layer, like you said, means opening your plant to the controls of the internet? Like how does this technology handle IT and OT separation?
Okay. First of all, IT and OT separation is done through one-way data diodes, like
Mhm.
PIMS system I talked to you about. It is a
Yeah.
perfect system to bridge between the OT layer and the IT layer. We never write. AI cannot write directly. We don't allow AI to write directly to the operational technology layer. OT layer, we never write it. One-way data PMS works as a one-way data diode. It just collects the data from the OT layer and send it to the IT layer. And if
Okay.
you talk about data security, we have various solutions on-prem air gap system that can be installed that will run internally so your data doesn't go anywhere.
Okay. 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 Understood. Understood. So, okay. So you have the tools, we have new technology coming in. That's all good. But the major hurdle for especially for Indian industries is to adopt these technologies, right? So, but uh, as we can see, the globally manufacturers are already moving towards a lot of predictive operations, and all of these things are being implemented in a global scale. Or am I wrong? Is it like an early stage? What are the Siemens, ABBs, and Honeywells of the world doing right now? Like, where are they? And Saika, just to ground our reality, I lost some time with the whole fire thing. So we can if we can quickly drift through the things, it will be great. Yeah.
Yeah, okay, no problem.
Yeah.
So when you ask about top and big companies like ABB, Honeywell, Schneider, Siemens, and all of them, yes, they have various serious AI and digital twin platforms. They have a lot of them. But the problem is they have made it for multinational big companies. Okay,
Mhm.
there is no uh, item that has been packed for a 200 or 300 people SME in India.
Okay. Okay.
Okay. Those people cannot afford that large, those softwares. They are actually meant for heavy and big industries or multinational
Understood.
companies. Okay, so that's where we come in. We are like bridging the gap. We are trying to make solutions for SMEs. We are trying to
Mhm.
find the different problems they are go through day-to-day operations, and we find the solution for that.
Okay. Saikat, so not just so when I say adoption, Indian factory owners, Indian manufacturers are generally very cost sensitive, right? I mean, so like they usually ask what happens to my investment if AI changes tomorrow, right? I mean, because we can see that AI is not evolving in a not changes. I would say like evolving is the better word, but it's not a linear change also, right? It's not a linear growth. So they will be asking the question, what if it changes? How then? What does it look like? So isn't it better? Isn't it safe for them to just hire a few more people? So this is. Do you also agree to this observation?
No, I don't, because see, hiring people is not going to solve a predictive maintenance problem. You have to understand that. You cannot
Mhm.
have a small plant in India cannot have high paid data engineers sitting there at 24/7 looking at your data. Nobody
Mm.
looks at your data at 1 a.m. at night, what it is, how it drifted. AI did that. AI, that's what AI is for. That's looking up at your data.
Okay. Okay.
So
Okay.
I would say
So you.
start small. So all the industries, I would say start small. Go for the
Mhm.
areas which will give you fast output, and then take it to the next level.
Understood. So you spoke about how there is a gap between the big players, global players versus a 200, 300 person factory, right? So let's say let's say they get this, they want to start on this predictive maintenance thing, and for someone who wants to start today, let's say what would the 6 month journey look like? Can you walk us through a very realistic, grounded implementation roadmap from day one to the full deployment? Like month one, this is what we do. Month two, this is what we do. And and maybe close that with an ROI detail also.
Surely. See, the first day you start implementing your AI
Mhm.
would be mostly in on your rotating machines, a predictive maintenance kind of thing. And after that, within the 6 months, you would see that your production area, instead of firefighting, most of the people working there are working with more efficiency than they have been before. Because before people were just firefighting all the time. Okay, this has happened. How to tackle this? This has happened. Well, most of the time, or the energy is being dedicated to tackling different problems that arises without warning. Now you have time to see what problem is going to come, how to handle it, how to smoothly take it forward and mitigate those kind of situations. That's how
Mhm.
it looks like. And after 6 months, you find that your shop floor is running much smoother than before.
Okay. Okay. So earlier, like just to conclude this section. So earlier, uh, all those things that the big companies implement were not available to the SMEs, but with the new technology, with AI, this is a big watershed moment for all the SMEs, right? So right now, so we spoke about the logistics front, we spoke about the commercial side also, and how it will also help staff on the plants to not just the machines to predict the maintenance, right? So, and also I'm assuming in, let's say, in industry like pharma, where the compliance and all those things are much more severe, and they
You
have
broke
years
up. You
of
broke
data
up.
to.
Sorry.
Sorry.
You broke.
Till
Yeah.
where could you hear me?
Yeah. I didn't hear you because you suddenly your voice was
Yeah,
breaking.
sorry. Yeah, sorry, guys. So, no, I was just saying that in an industry like pharma, where they have years of data to compile and the compliance is just very challenging, I'm like the whole invent of AI, I'm assuming will be much useful, like, right? So, when you said that 6 months, I'm interested in knowing, like, when the AI collects data and, all those information is compiled, after a year or a two, I'm assuming the AI will be, learning about a lot of trends when it comes to that particular plant, right?
Yeah, definitely. Definitely. When you talk about, say, pharma industry, okay, so
Mhm.
you have a lot of compliances to go for. Okay, anything going deviating from normal will be very bad for the whole industry itself. So that's where AI will come. AI comes in because with say batch processing and all those things, a slight deviation from normal would be detected by AI, which is very hard to be detected by human beings before things are deviated. So I have deviated so much that like it's on a hazardous level for the company.
So I would like to ask you something a bit, which is which is a bit of a controversial thing when it comes to AI, because we hear all these news of people getting replaced and all those things. So it might be a little uncomfortable. But if AI can predict breakdowns and basically run the maintenance, why would a factory, or does the factory still need as many engineers?
Definitely, it will make engineers. See, engineers nowadays are just firefighting. Something breaks down, they are running after that. Engineers should be doing real engineering job, improving efficiency, improving the product quality, and all those things, designing details. So that's where engineers, that's what engineers should be doing, rather than just firefighting. Something is down, how to repair it, who will repair it. Now, do I even have a spare for it to replace and get the plant up and running for that? So engineers are not doing any real engineering jobs work as of now. Okay, with AI to help them, they would be rather doing engineering job that they should be doing in a plant. So no, AI is not going to replace the engineers. AI is there to help them get more efficient.
So they are more enabling rather than replacing.
Yes, yes.
Right? Yeah, okay. So to some of our audience who would like to, let's say, implement or start their AI journey, or they have not started their AI journey, what should they do right now, right? Because let's say for a manager who is getting data from 5-10 guys, he can, can you just summarize that also, like how it would benefit someone who is not into this AI thing if they want to implement it right now?
I would say start small, whichever area you are feeling that is being your biggest problematic area. Start small there, and then you scale it to the next level. Say, for example, predictive maintenance is one of the best things to start the journey or AI journey to start with, and then you take it to the next level. Then it could be the power, then it could be your flow. If you are from oil and gas company, you can go for the flow management, gas management, or all those things. If there is a leakage, if there is the processes are inefficient, if it is a power plant, I would say there are safety norms that can be very well be done by AI. For example, you have in a big power plant, you can see a lot of CCTVs are everywhere. Okay, so with the help of those data, AI can detect if there is a fire or not, first. Second, are the people working there following all the safety regulations? Are they wearing helmet? Are they wearing their reflective jackets? If someone is working at a height, is he wearing a harness? Now, all those things. These safety compliances inside a plant is going to save a lot of human lives, as well as make the work easier to carry it out.
Right, right. Okay, right. Yeah. So I want just one thought that has been lingering in my head when we spoke about IT and OT is that so does this the model, the predictive model, the maintenance model, does it work completely locally? How is the distribution? How do you separate the cloud versus the local thing, or is it entirely local? Did I miss that? I just want to clarify on that. Yeah.
We have cloud models as well, and we have local models as well. There are some norms and regulation. For example, we did a project for Dubai government for the
Okay.
media division. Okay, they wanted the data to stay inside inside UAE.
Mhm.
they didn't want the data to leave there, leave UA. So there was
Okay.
two options. Either we had to go for cloud that is being hosted there, or they would provide us a on-prem server where we would be deploying our things. So they went
Mhm.
for their locally like UA-based cloud system, and we deployed it there. But we also have similar things. We can deploy it on an in-house server if you have. Definitely, you'll need the configuration to meet the kind of what kind of ML model you would be is required for you, right? Based on that, the
Mhm.
configuration changes. And also, there are a lot of local LLMs nowadays available, which will where AI tells you, okay, this is going to go bad, and it is going to explain you why it is going to go bad. What is the problem there?
Mhm.
Unlike any other
Understood.
SCADA or any other uh, system that exists there at this
Understood. Understood. So, in your experience, please be honest. What is the hardest part of getting an Indian factory to trust this? Like when you approach them, what is the hardest part? What is the one thing that they say, as they are not welcoming this technology, right? And what do you say to them?
See, they have seen a lot of hype that has been built before, like Industry 4.0, before that,
Yeah.
this sort of all those things, and they have spent so much money on them that it's difficult for them to trust something that is coming up and something new. But uh, I would say we have built on those failures. We have taken those failures that has happened in the past, and we have built on them. So with minimum risk, if you can, we say that with minimum risks, you see if what is the capex.
Mm.
You have a high opex, then definitely they would welcome a technology, something like that, which are going to make their life easier.
Is there any for instance you can give, like they said this, but then we give this solution so that then the end result this was. I think that would be interesting for our audience.
It has happened a lot of times. This is not the way. It almost
Yeah.
happens every time. So we have to convince them
Right.
that, let's say you go into a pilot phase of just 3 months, say, okay,
Mhm.
and you calculate how much you have saved during that 3 months and how smoothly things have worked. And that's how we try to convince them to start with. We always say go for a very small pilot where the capex
Mhm.
is low.
So
Then you build up.
where would you start them? I mean, is it an operational
Always
thing where you would start them?
always predictive maintenance. I would say always
Always
start at
ready.
predictive maintenance. For
Okay.
industries or manufacturing plants, yes, predictive maintenance. Or if there is a QC area for, say, a pharma industry, okay, say there are visual ML models which can actually detect if their packaging is proper or not, whatever the pills or the strips that are coming out. Okay, and they can like analyze those videos, even like on the real time, a 60 FPS video can be analyzed by a ML model, which has been
Mm.
trained for visual recognize or visual QC. Okay, because in a pharma industry, it's gets very difficult for those thousands and thousands of strips. There is no real way of a human can analyze all those things. Okay, that's where AI comes in. In textile industry, I would say their yarns, the cloth, they are kilometers long and are wound in big rolls. Okay,
Mm.
actually finding out where there is a defect is very difficult.
Like
Okay,
to the
that's where
centimeter level, you're saying, to the
yes,
precise level.
the precise centimeter level, you cannot do that. If you have a AI visual model and there are two high speed motors, one is unwinding and another is winding, it can detect at a centimeter level, okay, out of this many kilometers, this is the place where there has a discoloration.
No, that's very interesting. Could you give me another example from another industry, maybe an automotive industry? Because there's a lot of conveyor belts in an automotive industry, right?
Automotive industry, there are a lot of different processes. Now see, the parts that are being manufactured vary based on what they orders they have received. Now, a lot of time there are machining that has been done on them, and your tool head are getting damaged too early, or say unless and until the tool head breaks, there is no one to like look at it. Okay, an AI model, visual models can predict. There are different kind of vibrations that can predict that. Okay, this is the signature, how it's going to work. See, even a motor signature, a current signature in the motor. For example, AI is looking after that continuously, and those current signature, when it starts, it stops, it runs, this vary what kind of condition or the motor is being loaded and which way it is going. Is it a mechanical failure? Would be it is going towards a mechanical failure or electrical failure? Those signatures are different. Right. These are the places AI comes in and they detect, okay, this is going to be electrical failure. So either you take it down and replace the motor, or you send it out to have a quick look at the insulation of the motor. Okay, if it is a mechanical failure, one has to check if the bearings and other places are being uh, like if there is problems in there and they have to change it or not, or just greasing it is enough for them. Those things can be done after you have detected the problem.
Okay, yeah. So like if it's a motor that is, let's say, it's supposed to start in like a certain amount of time, but then it's taking a longer time, which might not be, caught by a human, or even, the data might not be that relevant. But I'm assuming from what you said, the model would see a pattern, right? So this is happening, this is happening, this is happening, and then it, consolidate it and then present. Okay, there is a potential problem with this motor, right? Am I right?
See, it is also not only one model that is analyzing it. Okay, there are various models already present inside the two, like inside that agent, I would say. A lot of different models are working on the same data. And then they do ensemble voting, saying that
Okay.
who has given what result. And the maximum they go by, okay, 5 models
You
might
mean
have
the
given
models, right? You mean the models inside talk to each other and
inside.
then they ask the questions.
Yes, then they vote amongst each other. That's how they also avoid false alarms.
Oh, okay, okay. Yeah, that makes sense.
That's how AI works. AI learns from itself. It is not, we don't, as a normal automation, we humans set a limit.
Mm,
Okay, it is rule based. Automation is rule based. AI is not rule based, it is context based. We give context to
okay.
the AI models, and then it learns on itself and sets its own thresholds and levels.
Understood. So that means that, so let's say an industry which has been using the traditional automation system for the past 20 years, the point from which they started to the point they have entered, there would be very small, minuscule changes and adaptation with the normal mechanical technology, whatever is evolving. But when it comes to AI implementation and predictive maintenance, am I wrong? Am I right to assume that within a year or two, we will have so much data that we can, let's say, a water plant can have a data on, okay, this is the amount of toxins that is going out, or like a lot of data would be getting very exponentially, giving inputs to the factory, right?
Yeah, definitely. So as you were talking about toxins going out of a plant, any kind of plant, it might be a chemical plant that are being given out in the to the rivers or any water body. Now, just imagine if it has been drifting, if more
Mhm.
is going out, but it is just by a minuscule increase in that. But AI can detect, okay, this is the normal thing that it has been doing, and now it has been increasing. Why? It can ask a
Mm.
question. Then the engineers or the people working there can look after that problem. what will happen? Otherwise, what will happen unless and until there is a big change in the toxin output? No one is going to notice it. Right.
Right. It might be too late for them to, kind of.
Exactly. Pattern recognition is the word I would say.
Yeah, these are all very life-threatening, very catastrophic, events that could happen. So I would like to know if you have come across any like an instance where your system has caught a very dramatic breakdown before it actually happened, has avoided it.
Yeah, it did. Like one of the plants here, but we have given our mechanical like system, vibration system and everything. So it did catch a very big breakdown beforehand.
Okay.
And it would have been like a lot of downtime for the company, and might have, it was a mechanical failure. It could have been life threatening if the whole system would have just broken and people working there would have got hurt. So yes,
Mhm.
it did. One of our systems did the prediction, and yeah, I would say we saved lives.
Are you able to, I mean, are you allowed? I'm not sure if, because since these are real case studies, I'm not sure to what extent you can, be open about it. But is there anything specific that you can, so that the audience can have a good takeaway in that?
Anything specific? I would say, okay, one of the projects we just finished on, it became live on 1st of March this year. So it
Okay.
is for a power plant here. They are taking water from, say, from the irrigation department, from the dams, 6 pipelines continuously supplying them water. It is a gravity flow initially, then there are pumping stations in between. Almost it is 20 kilometers away from the plant, and the plant has its own reservoir where they take the water for usages.
Mhm.
Now the thing is that they have to they have to give a demand of this much water they are going to need per month, or this month, that month. Okay,
Mhm.
even if they don't use that much water, they have to pay for the whole demand
Okay. Okay.
first. So what our system is doing now there, it is there. We have installed flows, like partial flow measurement systems there, which will measure how much flow of the water is being taken from the dam, from the pumping houses. Each of the pumping houses has their own uh, pressure as well as flow meters to see how much water has been transmitted. First of all, we can directly see the leakages at different points. We can determine where the leakages are. And now for the next 1 year, this
Mhm.
system is going to just gather the data. It is going to correlate the data against uh, the weather data, the current weather data, the plant output,
Okay.
how much the plant is producing, how much electricity is being generated, megawatt is being generated, what is the downtime, when was the downtime,
Mhm.
and still how much water has been needed. And now they are, from after 1 year, it's can going to start predicting how much the demand should of the water should be for each of the months.
Most of our time. So, audience, please drop any questions that you might have. We will take a few questions and let Saikat answer them.
I
But
can
I'm not
finally
sure.
see you and hear you now.
Awesome, awesome. So, Saikat, I was just wrapping up because we are out of our time. So, Saikat, this has been a genuinely insightful conversation, and thank you so much for being here. And I think this is the kind of a discussion this industry needs more of, right? And implementation of technology and all these things. And thank you
Yeah.
so for being the first guest on Engineering Meets AI. And for everybody watching, you can find the recording of this webinar, albeit with some technical glitches, at indiaautomation.com. We have a lot more content there. We have news insights, as I told at the beginning. If anybody have missed, we have a lot of data and news and insights and analysis on Indian industrial automation. So do check that out and stay connected. Our next webinar in the Engineering Meets AI series is coming soon. So we will announce it in our website, in our social media handles. So do keep an eye out. And until then, thank you. Thank you for being here, and we will see you soon. Thank you, guys. Bye bye.
Thank you.
Sakit, take care.
Thank you.
Thank you. Bye bye.